Mr. Wara here again. Can you believe it? It's another math video. I know. Hey, you may seem shocked. Mr. Wara is actually going to do another math video? You're kidding. Another math video. Hey, thank goodness you guys are out there in cyberspace watching these videos. I enjoy doing them. I hope you enjoy watching them. Today's lesson is 6.7. Whoa, we're just flying through chapter 6 here, and we're getting into some of the more challenging concepts, I would say, because today's topic says add and subtract mixed numbers. Okay, I'm not nervous. We have math on our side, don't we? And our essential question, which I like to always use the word learning target, it's the words that we use in our classroom, learning target, and our target for our learning is how can you add and subtract mixed numbers with unlike denominators. That becomes a vocabulary word we use, or a term that we use quite a bit. Unlike denominators, like denominators. Hey, either they're the same or they're not, right? But we can't do any of that. You know that, right? You know what's coming. Tell me what's coming. Unlock the problem. That's right, my friends. Real world, baby. Real world. Real world. Yes, Denise mixed 1 4/5 ounces of blue paint with 2 1/10 ounces of yellow paint. How many ounces of paint did Denise mix? Okay, so as I look into my problem, I ask myself, well, what operation should you use to solve this problem? Not only what, but why? Okay, well, when I look at this, I think to myself, when it's asking how many ounces of paint did Denise mix, it's suggesting a total amount. Therefore, I would need to use addition. Okay, my next question says, do the fractions have the same denominator? There you go. Now I'm wondering if, like in the previous videos, we had something where you estimated. So it says add 1 4/5 plus 2 1/10. It says to find the sum of mixed numbers with unlike denominators, you can use a common denominator. Yes, we are probably aware of that, aren't we? Been doing this a lot. Step 1, estimate the sum. So I'm looking at this, and 1 4/5, 4/5 is almost 5/5, so it's almost 2. So I'm going to say 2 plus, and then with our 2 1/10, 1/10, oh my goodness, that's hardly anything, right? So if we multiply that by 10, that would be just like 10 out of 100. 1/10, 1/10 would equal, right? 10 hundredths, and that's like a dime out of $1. Hardly any. We would just say 2. Equal, that would give us 4. Now it says find a common denominator. Use the common blah, 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 blah. Use the common denominator to write equivalent fractions with like denominators. Okay, when I look at those two, I can see that 10 is definitely a multiple of 5. 10 is a multiple of 10 because 10 times 1. So 4/5, I would want to make a like denominator here. So if I wanted a denominator of 10, then I'd multiply it by 2 to get that 10. Multiply that by 2, and I get 8. So I'm going to have 1 8/10, assuming that's what that blue box is for. And here, nothing changes. It's just going to be 2 1/10. So if I add them together, I'm going to get 9/10, and then here I add the whole number part, and I get 3. Am I going ahead? Probably. It says add the fractions and add the whole numbers, write the answer in simplest form. 3 9/10, I do believe, is in simplest form. So I'll write that just like that. 3 9/10. Woohoo! Yeah. Okay, I don't know why I did that. It sounded like fun to do it. Mathematical practices, did you use the least common denominator? You know what? We did. And it says explain. I'm just going to say this out loud. I'm just going to say yes, we did, because I knew that 10 was a multiple of 5, remember? So 10 is the least common multiple of 5 and 10. So the 10 had to be the least common denominator. Multiple and denominator. Multiples, if you're just counting multiples of a number. Denominator is just if you're going to use it in your fraction, that's all. Okay. Yeah. Now down here it says mathematical practice 1. It seems like we've been covering this mathematical practice a lot of times. We're going to do it one more time, okay? This is the time you might want to buckle up and put on your seatbelt. Here we go. Reviewing mathematical practice numero uno. It says make sense of problems and persevere in solving them. That's right, you need to persevere. When presented with a problem, I can make a plan, carry out my plan, and evaluate its success. Is it going to be a winner? Let's find out. What do we do before? Well, before I explain the problem to myself. Sometimes Mr. Ware talks to himself. It's okay, because we're doing math. It says, have I solved a problem like this before? What information is there that can help me solve the problem? What is it asking me to solve? These are all important questions. So in order to organize the information in the problem. Of course, you're going to persevere. Okay, monitor your work means checking it. Change your plan if it's not working out. It's okay to say, hey, this doesn't look right. Let me go back and check it. And of course, after checking, is my answer correct? That kind of thing. Is there some way I can show a model to make sure that I'm doing what the problem is asking me to do? Okay, goodbye, mathematical practice number 1. Boo! Yeah. So, explain how you know whether your answer is reasonable. Okay, so we did do an estimate, didn't we? Yes, we did. So let's come up here and take a look at that estimate. That estimate that we did was 2 plus 2. Remember, our answer is supposed to be 4. What did we get as an answer? There you see it, 3 9/10. Could that get any closer to 4? It's within 1/10. So when I think about the reasonableness, yeah, you know what? I can compare the answer I got to the estimate. And 3 9/10 is so close to the estimate of 4. So yes, the answer is reasonable. Let's write that down. There we go. Number 2 says, what other common denominator could you have used? That's right, we got the least common denominator. So what we could have used was 50. Remember, in a previous lesson, if you just multiply the denominators, that will always give you a common denominator. So I would say 50 would have been 1. Okay, there's others too. 50 is just 1. Could we actually think of others? Yeah, if you think of multiples, if we multiplied the 10 by 10, that would be 100, and 5 will go into 100 too, so you could use 50, you could use 100. There's a lot of different common denominators. It just makes the problem more challenging as the denominator, gets larger. Okay? Woohoo! Yeah. Page master. Yes, another example. Woo, yep-de-doo. Subtract. Okay. 4 and 5/6 minus 2 and 3/4. Okay. You can use a common denominator to find the difference of mixed numbers with unlike denominators. Yeah, we know that. Yes, because we've been doing these problems and we just get this math. It's getting easier. Now it says estimate the difference. Estimate. Okay, so we're going to look at that first fraction of 4 and 5/6. I look at that fraction carefully and I can see that, yes, I have 4 wholes. So it has to be at least 4. But then look at the 5/6. It's almost 6/6. And that would be another whole. So I'm going to up him one and say, you know what? He's closer to 5. Now, we're going to subtract by the next number, which we have 2. So it has to be at least 2. We have 3/4. And 3/4, when I think of benchmark, it's more than half. I don't know. I think I'd want to say that he's 3. He's more than half. And therefore, my estimate of this difference is 2. Okay, now, let's take on this mission. Find a common denominator. Use the common denominator to write equivalent fractions with like denominators. All right. And you know what? Maybe I should read step 3 too, since sometimes I go ahead anyway, which says subtract the fractions. Okay, subtract the whole numbers. Work to write the answer in simplest form. All right, I can do that, I hope. Okay, here we go. 4 and 5/6 is equal to, so we want common denominators. Well, I look at the 6 and I look at the 4. I'm looking at both the 6 and the 4. And yeah, I can multiply them. That's going to give me a common denominator of 24. That's going to be large. Now I could do that, or I might want to do something different, like find the least common multiple. So let me just go ahead and write some multiples. You'll probably see it right away. 6, 12, 18, 24. I could keep going, 30. Now if I do the multiples of 4, which is just like saying 4 times 1, 4 times 2, 4 times 3, 4 times 4, 4 times 5. All right, now you're looking at that. If I were to go even one more, yeah, let's do that. You can see that 24 is a common multiple of both of those numbers. But also, look at that. 12 is also a multiple that it has in common. So you can decide. Do I want to use a 24? It means I'm going to have to divide out a common factor later. Okay, so I know I'm going to have my 4, and I'm going to put my 12 since we've decided that 12. What do I have to multiply 6 to get to 12? It's going to be a 2. So then what I want to do then is multiply this by 2 over 2. Okay, and now that's going to give me 10 12s up here. Now this one here, the same thing. I'm going to leave my 2 here, use the time being. And then I also want a denominator of 12. Now here, what I have to multiply the 4 to get to 12, it was 3. So I'm going to multiply 3 over 3. This gives me 9/12. Right? Good so far. Yeah. Now, okay, now it's just time to subtract. 4 minus 2 is 2. 10 minus 9 is 1. So I get 2 and 1/12. All right? Had we taken that same problem, and I'm just going to extend here so you can see this, had I used 24, okay, what would have happened is that 6 times 4, yeah, would have been 24, but then you would have ended up with 20 up here because the 5 times 4 that you needed to multiply. So you end up with this larger number, 20/24. So it's still an equivalent fraction, okay? So this 24, and then here you would have had times, here to get to the 24, you had multiplied by 6, and the other one we had 18, okay? So you would have had 2 and 18/24s. Just trying to show you that then that would have ended up being 18 and 2 over 24. And then you see you could have divided out a common factor of 2. Works out the same. All right, moving on. Yeah, time to move on. Okay, for mathematical practice 1, again, we covered that. Evaluate reasonableness. Explain how you know whether your answer was reasonable. Well, we knew it was reasonable because remember, I even remember the problem. We had 5, didn't we? Was it 5 minus 3 equals 2? Let's take a look at our estimate. It was 5 minus 3 equals 2, so our answer should have been about 2. If you look at all our work, it was about 2, 2 and 1/12, very close. So that being the case, then here we're going to say, how do you know it's reasonable? Well, based on our estimate, my estimate was, so our estimate was 2, and our actual answer was 2 and 1/12. So I know that it's reasonable because I can compare my answers by comparing my estimate with my actual answer, and that is difference, because we were subtracting. My actual answer, I can see that, what would you say, that my answer is reasonable? Okay, yay, woohoo, yeah. Now it's time, share and show. That's right, my friends, share and show. So this might be a good time for you guys to take the video, put it on pause, then come back and say, all right, I'm ready to see how I did, Mr. Wara. Hey, that's a great idea. Good idea. I think you should take that idea. Okay, now, it says use a common denominator to write equivalent fractions with like denominators and then find the sum. Write your answer in simplest form. Okay, well, I'm looking 5 and 4 right away, and I see a common denominator of 20. So I'm going to go ahead and put that in there. 20 and 20 here. It looks like I also have a 4 there, and I have a 7 there. All right, now what do I have to multiply 5 to get to 20? Is a 4, so I'm going to be multiplying the numerator by 4, which means I'm multiplying by 4/4, if you will. So it gives me 8/20. Over here, the basic algorithm says, hey, I multiply that by 5 to get to 20, so I multiply this by 5. Okay, it's going to give me 15. That's how we make equivalent fractions. That's what those are, right there. Right, equivalent fractions. Okay, and now I add those together, and see I have 11 for the whole number part. 8 plus 15, last time I checked, 23. Oh my goodness, it's 23 over 20. The problem with this one here is I already have a whole, right? 20/20 is another whole. So I could rewrite this. I don't know, you could write it different ways, but I'm going to write it this way so you can see what I'm doing. There's my 20/20. There's 3 left over up there. Okay, so that way I'm going to get 12 and 3/20. Woohoo! Yeah. Oh my goodness. Could that be any easier? Hey, people, come and look at how easy this is. Find the sum. Write your answer in simplest form. So in all of these problems, I'm always going to look at the denominator. Can I find a least common denominator by looking at it? Yeah, I see it. But you know what I'm going to do this time? Just to change it up, I'm just going to multiply those so that you can see what happens when you don't worry about trying to find the least common denominator, but you just multiply the denominators. So this is going to be 3/4. I'm going to multiply just this part here by the tenths over there, because that's all we're going to do, plus 3, and that's going to be 3/10. And of course, I'm going to multiply that by the fourths. That's how I'm going to end up with 40. Now I get 2, I'm going to get 30 over 40. And then I add that, I'm going to get 3. And then here, I'm going to get 12 over 40. That's going to equal, now we have 5, because I'm adding the whole number parts. And the top is going to be 42 over 40. And I have another whole here, right? I have 5 plus 40 over 40 plus 2 over 40. That's going to give me 6 and 2/40, or if you will, 6 and 1/20. Wow. Woo, right here at the bottom. Okay, my answer reasonable. Here I have about 3 plus here, it's not even half, pretty low. I'm going to just say that's 3. That's 6. Yeah, I have about 6. So, yes, I like it. Next one. This one here, I recognize 12 right away here, so we just do our 5 3/4. Okay, did thirds and fourths, so that way I can get a common denominator. Okay, now I have my common denominator. I can just go ahead and add the whole parts. Now I have 6 13/12. I have another whole in there, so that's going to be equal to 6 12/12. Plus, there will be 1 left over. So that's going to give me 6 plus 1, which is 7, and 1, 12. Okay, I don't know if I want to use 50. That's going to be really large. So I have to know that least common denominator I can get here, I could use a 10. So let's do that. I have to multiply this one by 2 over 2 to get that denominator is 10. Here I don't have to do any changes. I already have the denominator I want. Now I have 3 and 8 tenths plus 2 and 3 tenths. Here I have 5. Now I have 11 tenths. I have another whole there. So I say 5 and 10 over 10 plus 1 over 10. So now I end up with 6 and 1 tenth. Woohoo! Yeah. Oh my goodness, it's time. Is it time? Do I hear it? Yes. From afar. Mr. Warrock, it's time for you to get off the air. Okay. All right, my producer's pushing me. All right. Hey, you guys. It's been an honor having you with me doing another math video. Yeah, we rock. 5th grade rocks. Now, live long